Hello and welcome to The Explainer. Today, we're diving into a process that honestly feels like something straight out of an alchemist's lab. We're talking about the intense chemical journey it takes to purify one of the planet's most precious metals, platinum.
So let's just jump right in. How on earth do you take a dull, kind of messy lump of mixed up metals and turn it into a gleaming, perfectly pure bar of platinum? How is that even possible?
Well, the answer, as you can probably guess, is not exactly simple. It's really a kind of modern-day quest, one that involves a whole lot of fire, some incredibly powerful acids, and honestly, some seriously clever chemistry.
So let's get started on our platinum purification quest. And like any good quest, the first thing we need to do is get our gear together.
Every adventurer needs a toolkit, right? And ours is packed with some pretty serious stuff. Of course, we start with our raw material, the platinum alloy. But to actually refine it, we're going to need sodium carbonate, two really potent acids, that's hydrochloric and nitric acid, and this interesting little salt called ammonium chloride. Oh, and you can't forget the acetylene torch for some extreme heat.
All right, let's get to our first big challenge. I'm calling this one trial by fire and acid. This is really the brute force part of the whole operation, where we start breaking that raw material down.
Now, you can't just throw this chunk of metal into acid and hope for the best. You've got to make it vulnerable first. So it gets melted down in a crucible, and here's a clever trick, a little bit of copper is added. This actually helps reduce the silver content, which prevents some major headaches later on. Then, that new alloy is rolled out really thin and chopped into tiny pieces. Why? To create as much surface area as possible for the chemical attack that's about to happen.
And that chemical attack comes from a truly legendary substance, aqua regia. The name literally means royal water. It earned that name centuries ago because it's one of the only things in the world that can actually dissolve the so-called royal metals, gold and platinum. It's just a crazy corrosive mix of hydrochloric and nitric acid, and it is the absolute key to this whole thing.
So, what happens when you drop those little metal pieces into the royal water? Well, this is where the first great separation begins. Our main targets, the platinum and gold, dissolve right into the acid, becoming part of the liquid. The more common metals like nickel and copper do the same. But, and this is crucial, the other really stubborn platinum group metals like osmium and iridium, they don't dissolve. They just become a black powder at the bottom. And then there's silver, which is a bit of a complication. It reacts and forms a totally separate solid. Just like that, everything starts getting sorted out.
Okay, so we've used brute force to sort the metals into liquids and solids. Now we've got to switch gears. We're moving from a sledgehammer approach to the fine art of precision chemistry.
So how do you get that valuable liquid away from all that solid gunk?
First, you gently heat the whole thing to boil off any extra acid that's still hanging around. Then you dilute it with some distilled water and just let it sit. You give it time for all that black powder and silver stuff to settle to the bottom. After that, a simple, careful filtration is all it takes to separate our precious liquid, which now holds all the platinum and gold.
And now for the real magic trick. How do you get only the platinum out of that liquid? This is the absolute climax of the separation. You slowly pour in that ammonium chloride solution we talked about earlier. And as it mixes, this incredible chemical reaction just happens. The platinum gets snatched out of the solution and turns into this vivid yellow solid that slowly drifts down to the bottom of the beaker. It's a pretty amazing thing to see. Now, this is a super important point. That yellow powder, that's not pure platinum. Not yet. It's actually a compound called ammonium hexachloroplatinate. You can think of it like the platinum atoms have been trapped inside a sort of chemical cage. We've successfully isolated them from everything else, which is great, but now we have to figure out how to set them free.
And that brings us to the grand finale. This is the fiery transformation that will finally turn that yellow chemical compound back into pure, precious metal.
So, how do you break open that chemical cage? You go right back to fire. The yellow powder gets filtered, washed clean, and then dried completely. After that, it gets heated up until it's literally glowing red hot. This intense heat makes the compound decompose. Basically, all the other elements burn off into gas, leaving behind pure platinum. but in this really weird porous form called a platinum sponge. And to get from that strange sponge to the solid, shiny bar of platinum we all recognize, you need to hit it with an acetylene torch that can reach an absolutely mind-boggling temperature, 1,800 degrees Celsius. To put that in perspective, that is hotter than lava from most volcanoes. This final incredible blast of heat is what guarantees you get that ultimate purity.
So our quest for platinum is a success. But, a good alchemist never wastes anything. So what about all that gold and silver that we separated out earlier in the process?
Well, that's the beautiful part of this whole thing. It's incredibly efficient. The gold, which was still swimming around in that liquid after we took the platinum out, is recovered using a totally different chemical key. And the silver, remember that solid sludge from way back at the beginning? It gets recovered from that using yet another unique chemical process. Nothing is wasted.
And this, right here, perfectly illustrates the core idea behind all of this. Refining isn't just one big process. It's a whole cascade of smaller, targeted ones. Each step uses a unique chemical key that's been designed with precision to unlock just one specific element, while leaving all the others locked away for their own turn. When you see this whole intense journey, from a simple, mixed-up alloy to a pure, perfect metal, it really makes you think, doesn't it? Is something like platinum valuable just because it's rare? Or does its value also come from the incredible amount of struggle and knowledge and sheer ingenuity that it takes to reveal its true form? It's something to think about. Thanks for joining this explainer.